To this point, we've focused on finding solutions to a single equation. We could obviously extend this to further include a set of simultaneous equations. So, for example, we may have a set of equations f1 that is some function of vector x1 to xn being equal to 0. At the same time, you could have a second function with the same vector of x to xn, and so on to some nth function, which is also a function of vector x being equal to 0, and we may want to solve these simultaneously. Now we can use matrix methods. We'll discuss this later. But let's look at another way of solving these types of equations. So in general, a set of linear equations are written in the form f of x being equal to a1x1 plus a2x2 all the way to an xn minus some constant, and setting that equation to 0. Now, all algebraic and transcendental equations that do not fit this form are termed nonlinear equations. So, for example, we may have the equation set of x squared plus xy being equal to 10 and y plus 3xy squared being equal to 57. So now how do we solve these equations? Well, if we set our first equation and label it u of x and y, and set that to, say, x squared plus xy minus 10, and set it to 0. And we do the same thing for equation 2, that is v of xy being equal to y plus 3xy squared minus 57, and set that to 0. Well, we could use open methods to solve these two equations, but in order to do that, we're first going to have to reform them. So, our first reformation might be of the form x of I plus 1 being equal to 10 minus xi squared divided by y at I, and y of I plus 1 being equal to 57 minus 3xi yi squared. So what I want you to do, starting at an initial point of x naught equal 1.5 and y naught being equal to 3.5, I want you to use fixed point iteration and solve the following two, well, the set of these two equations to 2 iterations. So once you've done that, write your answers or thoughts in the discussions below. Then I want you to reform these equations such that x of I plus 1 being equal to square root of 10 minus xi yi, and yi plus 1 being equal to 57 minus yi divided by 3xi. Firstly, can you see how we got from the top two equations to these bottom set of equations? Secondly, I want you to carry out the same procedure that you did in our blue example, And then I want you to discuss what happens to y in each case. And what does this say about the convergence criteria for nonlinear equations using open methods?